Okay, so today what we're going to do is we're going to begin our look at volume, which is another one of the measurements that we're going to be working with. So we've been talking about perimeter, which is just the distance around, which is just measured in plane units, right? We talked about area, which is the space inside a flat object, right? A two-dimensional object. And we measure that in square units or units squared, whichever way you prefer to write them. Okay? And today what we're going to do is we're going to look at volume. Now, frequently volume is confused with another measurement that we will talk about later. Volume literally means the amount of space an object takes up. Okay? So it's measured on the outside of the object. Okay? So don't think of it. So if you're measuring the volume of a cube, it's the space on the outside. How much air does it displace? How much space does it take up, right? Not how much stuff will fit inside of it. That's a different measure, and we'll talk about that later. Okay? So we're going to be measuring on the outsides of objects to find out how much space they take. Now, if you think of a cube, right? So think about, maybe this is not a cube, but think about this thing, this object. It has height, it has width, and it also has depth, right? So this is what's called a three-dimensional object because it has three dimensions, yeah? So that's what volume is used to measure. So we're going to go to the book and look at the definition of volume, and then we're going to talk about how you compute volume a little bit, but more than that, we're just going to be talking about the units, and then we'll do a lot of computations later. So we're really not as interested in computing it right now. We're just talking about the units. Okay? So here we are, and here's their definition of volume. Volume of a three-dimensional object, right? So in order to have volume, it has to be a three-dimensional object, is simply the amount of space it occupies. So volume of a three-dimensional object is simply the amount of space that it occupies, right? Okay. Pardon me? So what we're going to do today is we're going to think about the units that we're going to use. So that's all we're really worried about today. And the units for volume are measured in what are called cubic units. So you can either write it out as cubic units, or we can write it mathematically as units. Does anybody remember what cubic is? Yes. An exponent of 3. So units cubed. A power of 3 is units cubed. Because when you're doing units, you have, if you're doing volume, you have length, you have width, and you have depth. So that's 3 things multiplied together. So when you multiply the units times themselves 3 times, that gives you that cubed, or a power of 3. Okay? All right. So far we've talked about 3 different types of measurements. If we're just measuring a straight line, that's in just plain units. If we're measuring area, that's in units, what? Squared. Good. And then now we're going to be measuring volume, which is in units cubed. All right? So you just see we're just extending that every time. However many things you have measured, however many measurements you have in your calculation will tell you what the exponent is going to be for each one of those units. Yes? Okay? So, if we have 1 centimeter by 1 centimeter by 1 centimeter, that's 1 centimeter times 1 centimeter times 1 centimeter. 1 times 1 times 1 is still what? 1. Centimeter times centimeter times centimeter is centimeters cubed. Right? And so that's how we end up with the cubed. We're multiplying the units times themselves 3 times. We can't really multiply a unit, and so that just gets an exponent to show that there are 3 factors of them. Okay? So we're just expanding that. Now what we're going to do today is we're going to look at just some volumes of objects that are already divided up into little squares, your little units. Where we're just counting the number of squares. Then we're going to talk a little bit about converting from one type of unit to another. And we've done that before as well, which amounts to another chart that you have to memorize, right? We talked about that before. So let's take a look at some of these. Okay. So first of all, we're given some shapes here, and you see that they're just divided up into square units. So if you have shapes that are divided up into square units and they're flat, meaning 1 unit deep like the first one, how could I find the volume? Just count them up, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's 16 units what? Cubed. I don't know what they are, so I just call them units. Right? Now this one is not 1 unit deep, it's 3 units deep. So instead of counting, I can simply use a bit of a formula. And remember, the formula for volume of a rectangular solid like this is going to be length times width times depth. Okay? So how long is this thing? 6 units, right? How wide is it? 3 units. And how high is it? 3 units. And it really doesn't matter depth, width, height. Just have all 3 sides counted up. Which 6 times 3 times 3 is? It's a 6. Come on. 6 times 3 times 3 is? You're supposed to have your calculators out in front of you every day, right? There we go. 54, and we don't know what kind of units they are, so we'll call them units, and units to the 3rd power are cubed. Good. Okay? All right. Now, if you look at this last one, it's a combination of shapes. This part of it is just 1 unit deep. Do you agree? So I could just count out those, but this part of it, right, has width and depth, right, and height. So that one we could use the formula for. So first of all, let's just do this part. How many units is that? 12 of them, right? So that's 12 cubic units. Then I need to add in the rest. Well, the other thing has more depth than just 1, so that means one of the measurements is not just 1 like the other one is. So it's 3 units high. And yes, I'm doing them out of order because I want you to show you that it doesn't matter, okay? Which one you call which. We've already done this, so I'm going to just mark it off. It's 2 units deep, and it's 4 units wide, which gives me a total of what? 24 units what? Cubed. There you go. All right. And now, since I'm putting those two together, that just means add them like we did the composite shapes yesterday. So that gives me a total of 36 cubic units for this shape. All right? So, pieces, you can't do it all at one time. Okay? Do it in pieces. Yes?
But it's 2 cubes, so would it be 6? Or is it
No.
So is it
It's just cubic units plus more cubic units. Think of it, it's like oranges plus some more oranges just stays oranges. When you're adding, it just stays the same. Which when you multiply, that's when you change the exponents, because exponents mean multiply. All right? Good question, though. Okay. So, let's look at the next part of this question. We've found the areas of the volumes of all of them. Which one of these has the greatest volume?
the middle?
Yeah, B did. The least volume?
The first one.
The first one, A. Okay? All right. Now, we want to think a little bit about units. Now, remember, we have some visuals. We talked about these before. When you're just visualizing units, a millimeter is about the thickness of a coin. Remember that? We talked about that. A centimeter is about as wide as your fingernail. Then a meter, stretch out your arms kind of, right? Okay? And so think about what units would be most appropriate for the following objects. So, if you have a textbook, what units would you measure that in? Centimeters, but of course we're doing volume, so it would be centimeters what? Cubed. Centimeters cubed, right? Be too small for a meter. How about a paper clip? The volume of a paper clip. Definitely millimeters, what? Cubed. Excellent. Thank you, guys. An elephant. Meters cubed or cubic meters. Yes, good. An apple. Centimeters cubed. A mobile phone. Centimeters cubed, probably. Now, we had some argument about this one in the other class because an eraser.
Centimeters.
Depends. Are we talking about an eraser on the end of a pencil? Or are we talking about an eraser, those little rectangular ones that y'all use, right? Yeah. So it depends on what kind. If it's let's do it two different ways. What about the eraser on the end of a pencil? Millimeters cubed. What about the rectangular ones that y'all use? Centimeters cubed. So it depends on the kind in that case. Yes.
Is a centimeter like an inch?
No, a centimeter is about as wide as your fingernail. Small, much smaller than an inch.
What's like an inch?
2.52, like 2 fingernails.
Okay? Come on, focus. Let's get back to it. So, a truck.
Meters cubed.
Meters cubed. Yeah. A football. Probably cubic centimeters. A single plant seed. Millimeters cubed. Right? So, when you're measuring different objects, think about the appropriate sized objects, appropriate measurement to use for each object you're measuring. Right? Okay? You wouldn't want to measure a paperclip in cubic meters because it would be a tiny, tiny, tiny little decimal. Right? Wouldn't make sense. Now, lastly, what we're going to do today is we're going to talk about converting units. And remember, for converting units, I taught you that little jumping trick. Right? Now, if you want to memorize all of the multiplication and division, you're welcome to. Okay? But it's a lot easier just to remember the jump trick, right? So, let's talk about that. Remember that in the middle, you have your basic units. Meters, whatever. In our case, it's always meters because that's what we're measuring using those. Our basic unit is meters. As I go to the right, what do I get? Deci. Then what? Centi. And then milli. Good. As I go to the left, I get what? Deca, hecto, and kilo. Excellent. Good job, guys. Okay? So, remember those. Now, if you want to abbreviate them, the abbreviation for deci is just plain old D. Centi is plain old C. And now it's centimeters, decimeters, right? And millimeters. When you're going on this side, that's also a D. To indicate it's the bigger one and it's deca, you just simply use a capital D to tell the difference between those two. Okay? And then hectometers and kilometers. Okay? So if you want to abbreviate, that's perfectly acceptable, right? All right, now, and what I told you to do is go from one unit to another. All you need to do is jump. And how many jumps tells you how many times you move the decimal. And jumping in which direction tells you what direction to move the decimal. I also want to remind you, so say that we have 48 kilometers. Where is the decimal in 48? Behind the 8. Where is the decimal in any whole number? At the end, right? So every number has a decimal in it, whether you see it or not, right? If you don't see a decimal, then it's always where? At the end, right? And so jumping is going to tell you how many places to move it and in what direction. Now, when you're just talking about plain units, all you need to do is however many jumps you move the decimal one place. But what happened when we talked about squared units? What did we do? We double them. Yeah? So now we're talking about cubed units. So what do you think we're going to do? We're going to triple them. Exactly. So if you jump twice, we're not going to jump just twice. We're going to jump 2 times 3 or 6 times. That's how many times you're going to move the decimal. Okay, so we're going to look at some examples of that. Now, I'm just going to put a few up here. Doesn't really matter what they are, and because the process is the same. So let's say we have 16 kilometers cubic kilometers, and we want to take that to meters cubed. So we start at kilometers and jump to meters, which is 3 jumps to the what? To the left.
Right.
No, to the right. Your other right. Yeah, to the right. So where is the decimal in a 16?
At the end.
At the end. All right? And I'm moving to the right, and it would be 3 jumps if it was plain old units. It would be 6 jumps if it was squared, or what? 9 jumps if it's cubed, right? So if it's plain old units, you just use however many there are. But if it's squared, you double them. But if it's cubed, you triple them. And 3 tripled is 3 times 3, which is 9. So I've got to move that decimal 9 units to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my decimal. Now I've got to hold all those places. So what am I going to put? A bunch of zeros. And there's your number. It's a big number. So do you see why you need to use the appropriate kind of units? Because that would be a horrible number to write. Okay? And of course it would be meters cubed. Don't forget your unit. Okay? So because it's units cubed, you're just gonna multiply however many jumps by 3.
If you don't remember the units, is your answer wrong?
Absolutely wrong. Right? Okay, let's look at another one. And again, doesn't really matter. Let's say we've got,
48.
we'll do 48 in a minute. It's in your homework. You can do that one yourself. 1.24 meters cubed, and we want to change it to centimeters cubed. Okay, so again, go to our chart, and we start at meters, and centimeters is how many jumps? 2 jumps to the right. So we pick 1.24, but since we're doing cubic units, it's not going to be 2 jumps, it's going to be 6. So 1, 2, 3, 4, 5, 6 puts the decimal there. What do I do in place of put zeros in all those missing places? So our final number is 1240000. So 1,240,000 centimeters cubed. So it's just a matter of counting how many places you're going to move and multiply it by 3. All right? Okay.
What if we go from kilometers to millimeters?
And then it's a long and goofy process because it wouldn't make any sense. But you could do it. It's 1, 2, 3, 4, 5, 6 jumps. So 6 times 3 is 18. We'd have to move that decimal 18 places. And some of us aren't doing that. Okay? All right. How about this one? Say we're going from 16 centimeters cubed to meters cubed. Yes?
Can I go to the nurse?
Yes.
Painkiller?
Now, so we're starting off at centimeters. We're going to go to meters. That's 2 jumps to the left. So we've got our 16, our decimal's right there. But since we're talking about cubic units, it's not going to be 2 jumps, but 6. So 1, 2, 3, 4, 5, 6. That puts our decimal there. Now what am I going to have to do in place of all those spaces? Put your zeros in. And since it's a decimal number, what do we always put in front of it?
0.
A 0. So, and of course, do not forget your units. If you do, then it's wrong. Okay? Now, if you want to remember that means divide by 100,000, go ahead. But I think for most of you, it's probably going to be easier to remember 2 jumps. All right? Makes no difference. If you want to do it the other way, that's not a problem, right? But this always works, and you always know how many jumps to make, okay? So again, you do it the way it works for you. Don't ever do something just because I told you that's the way I do it, right? But this will at least give you a good understanding of why you're moving one direction in some and the other direction in others. Okay? Yes?
When do we get a
Oh,
competition results back?
Not a part of this problem, is it? Hold on. Relevant questions only, please. Yes?
Are we ahead of some other classes?
No, not a relevant question. Okay? All right. So, let's get your homework. You're going to get started on it. If you finish it, then you don't have homework. So all we're going to do is do some unit conversions. So you're going to be on 13A2. So exercise
Page 20.
13A2.
It's page 268.
Page 268. Excellent. Everybody got that? Exercise 13A2, page 268. Some of them you're just converting from units, jumping like we just did. Others, you're going to be given a certain number of units, so you may have to multiply, you may have to divide. So think about converting back and forth to different units if you have more of them. Okay? So that's your exercises. Again, if you finish today, then you can work quietly on anything you want to, have free time, but finish these first. And if you don't finish it, then it is homework.